Hey everybody, it's Mr. N, and this is our next lesson. It's 11-2 from our Big Ideas book, and it's on areas and sectors of circles. In the last section, we talked about how we can get the formula for the area of a circle. We said the area is pi r squared, and we developed it from knowing that the circumference is 2 pi r, and that this length is half of that, the circumference, and then this would be the other half, and then we can multiply this by the height, which was the radius there as well. So this is how we developed it, and we came up with pi r squared. So the area of a circle, we know it as pi r squared right there, and that's something that you should have already known. But now what if we want the area of part of the circle? Well, we can call it a sector of a circle, a segment in a circle, those types of things. So let's take a look at what we got here. So suppose we had a part of a circle, and I'm going to scroll this up here so we can take a look. And if we had right here, this, what we're going to call is a segment of a circle. So that's what we will define as a segment of a circle. So the area of a segment is the area of the sector minus the area of the triangle. So here's what I'm going to do. In order to find just this green segment, I'm going to take this whole sector, and we learned in the last section how to find this whole sector, and then we're going to subtract out the triangle that I can make from this. In other words, that triangle like that. If we subtract this out, what's left over right here is this piece that we will call the segment of a circle. So let's recall how we find the area of a sector first. To find the area of a sector, we said we're going to take our formula for the area, which is pi r squared, and we just want a portion of this. So this right here, this m over 360, this is the part over the whole circle, which is 360 times the pi r squared. So this gives me my portion that I want, and that would be this sector ABC. And then we can find the triangle in here, and it'll give me that segment if the problem asked for the segment. So, as we said, the segment of the circle right here again is the region bounded by the arc and its chord. All right, so now back to the next thing that we're going to learn, and this is population density. So density is just what it is, how you learned it in science classes. And it's just simply a ratio of how much you have in a confined space. So over here, if we talk about population density, and the only reason I'm bringing this up is because you're going to have a couple questions in your homework about it. So population density, this would be the number of people, how much you have in the confined space, which would be the area of land. So that's what the population density would be. So the number of people over the area of the land. So you can go ahead and use this on those problems you'll have in the homework. All right. Population density is usually given in terms of square miles, but it can be expressed using other units such as city blocks. All right, so let's turn to page 322 in our student journals, and we're going to do those problems 1 through 9. All right, so here we go. And the first one says, find the area of circle M. Well, we know that the area is going to be pi times the radius squared. The area will be pi times the radius will be 2.5, and we're going to square that. So the area will be 6.25 pi. And just leave it in terms of pi. Over here, we need to find the area of circle R. The area is going to be pi times the radius squared again. The area equals, this will be 49 pi when we take that 7 and square it. All right, next up we have to find the area of a circle with a diameter of 1.8 inches. So the area and the diameter is 1.8, so that means the radius will be 0.9. So pi times 0.9 squared, which will give me 0.81 pi. And these are, I didn't put the units, this is going to be square inches, and this will be square centimeters, and this will be square meters. All right, moving on to the next one. We are going to find the diameter of a circle with an area of 10 square feet. So this is our area this time. Whoops, let's use the right tool here. This is our area is 10, and we know that it's pi r squared, and we can solve for this. So 10 over pi, and we take the square root of that, that's going to be our radius. To get our diameter, we have to multiply this by 2. So 2 times 10, the square root of 10 over pi is our diameter. I'm going to leave it like this. If you wanted to simplify this as a decimal, you would get the diameter equaling 3.57 feet. All right, next one. The radius of a circle is what we have to find with an area of 65 square centimeters. So 65 equals pi r squared. 65 divided by pi, and take the square root of that. That would be our radius. And again, you can leave it like this, but most likely on your homework they're going to want you to change it to a decimal, and that would be 4.55 centimeters. All right, moving on to the next one here. We've got the area of a circle with a radius of 6.1 yards. The area equals pi times 6.1 squared. We can multiply this out, and we will get 37.21 pi square yards. All right, let's see what we got next. We've got a few more problems here. 7 is the areas of the sector, and here is the sector, and this is the sector from, let's get a color here, P to Q to R, and it's 140 degrees, and we have a radius of 4. So remember, we want the part over the whole. We know the whole all the way around is 360, so we want 140 out of 360 times this pi times the radius squared. And if we multiply all this out, we are going to get 6.22 pi, and this would be square centimeters. If you left this as a fraction, it would be 56 over 9 pi square centimeters. Okay, and the last one here with the sectors. And then I'm going to do another problem after we do the density on number 9. So over here, we have 4.1 square, and we need to find the area of the whole circle. So remember, this part, 25 out of the 360 times pi r squared, gave me 4.1 square feet. So the whole point of this is to find out what the r is. And so then we can multiply each side by 360 over 25, and then divide by pi and take the square root. So to write all that out, we're going to multiply by 360 over 25, 360 over 25, because those will reduce, and divide by pi. So divide that answer by pi, and then you'll have r squared equals this, which would come out to be 18.793. And then we can take the square root of that and get the radius as being 4.335. Now we can just say the area is pi times 4.335 squared, which would give me an area of 59.038 square feet. Now, this is in class where I would ask you, does anybody see another way to do this problem? And usually I would get plenty of responses, and here's how you could do it. If 25 is the part over the whole, we could say 4.1 is the part over the whole, and just set up a simple ratio. So x would be 4.1 times the 360 cross multiply divided by the 25. So it's just simple cross multiplying, and that will give me 59.04, same answer as down there. All right, so let's move on to the last one here, number 9. About 70,000 people live in a region with a 30-mile radius. Find the population density in people per square mile. So think about this. Think about this. We've got this circular region with a radius of 30, and 70,000 people are in here. So we have the people over the area. So the people over the area is our population density. And in this case, we've got 70,000 people, and the area is going to be pi times 30 squared. And that would give me 24.76 people per square mile. Okay, so I wanted to do one more problem for you. Let's slide this up so I can get a little bit more room here. And I wanted to find the area of one of these, the types of problems that we have with the sectors or the segments of a circle. So in other words, suppose I had this circle here, and I'll draw a circle, and I had a sector here, say we'll call it, this radius, we'll say that it's 12, and we'll say that it made a 60-degree angle. We're going to keep it easy right now with a 60-degree angle. And I had this sector that I wanted to find right in here. What is the area of that shaded sector in there? All right, so what we have to do is we have to take, or this segment I should say, we have to take the whole pizza slice, the way I like to think of it, which is the sector, subtract out the pizza that has the toppings, and I will be left with the crust. So this is the part I'm subtracting out, this triangle right in there, and I'll be left with the crust, which is what I'm looking for in this problem. All right, so we've got this sector, and this is going to be 60 out of 360 times pi times 12 squared. And working all this out, I would get 24 pi. 144 times 60 divided by 360, or you could say 144 divided by 6. And then now for this triangle, if this is a 60-degree angle, and these are both 12, well, obviously these have to be the same. So what I end up with is an equilateral triangle, right? If this is 12 and I'm looking at this triangle in here, I end up with an equilateral triangle. So this is 12 by 12 by 12, and I need to find the area of an equilateral triangle. Well, that's pretty simple, because what we can do, if you recall, since this is 12, that's 12, that's 12, we can solve for this height. That's a 60-degree angle, which would mean this piece is 6. It's also half of that, right? We're going across the 60 because it's a 60, 30, 90. And this piece would be 6 root 3. So the area of this would be 1/2. The whole base is 12. And the height we just found to be 6 root 3. So the area would end up being 36 root 3 of that piece. So now for the area of this sector, I would simply take my 24 pi and then subtract out the 36 root 3, and what is left over will be that piece right there. And I can work this out as a decimal, and that would be 13.044, and we'll just say square units. All right, so hopefully this lesson wasn't too bad. These can get a little tricky, but you need to practice a couple on your own, and I can go over more later. So hopefully this helped out. Thanks for watching. Hit that like and subscribe button, and I'll see you in the next video.